Okay, so let's start with the project that we have for you. Okay, so this is your project, right? So I hope that the software is installed in your PC, right? So these are the demo of how you are going to install the project. Okay, so meanwhile I have the 2019 and 2024. So I have opened up the 2019. When you open up the 2019, so you will see this screen, right? Okay, then after this what you are going to do is click on create project, right? I'll also make a project folder for you, so let it just fetch. Okay, so next, okay, now I'll just do one thing. Okay, so this will be for you, which is like Nexys board A7, for example. Okay, so it is lab 0, so I have written it as a lab 0, and also you can select a folder from here. So I have done this thing. Now click next. Okay, now also click next. Before this, make sure the RTL project is being selected. Then next, select target language as Verilog, because your professor just mentioned right here is the Verilog. Okay, this thing, as this .v function represents the Verilog. Okay, so let me just find Verilog. Okay, so here your professor just told you you will use different Verilog design instead of blinky.v. Okay, so what we are now doing, I have selected here as Verilog, simulator also Verilog. Okay, click on next. Okay, so here your professors told you that here we are not going to implement this on the board. Okay, so board is not required, so that is why I am not using the board. So I am just leaving the XTC thing. Okay, now here you have two options: either search in the board list as Nexys. Okay, I hope you have Nexys 100. So Nexys. Okay, so here you can select either Nexys 100T or DDR. Okay, if you are having the 100T, then if you are having 50, so you can select the 51. So if you are having the 100T, so you can use this thing. Or if not, you are not searching this thing right here, so go to the part, select Arctic 7, package will be 234 324, right? Speed will be -1. Now here you can see this 101, so you select this, click next. Okay, now finish this. Okay, okay, now let me just show you that what you will do after the what is the next step right here. So professor told you that we have to make a file named as FourFunctions. Okay, so we have to click here as a add sources. We have to click on create design sources, then next create design, create file, write for functions. Okay, click OK, then finish. Now here it will ask you some things, right? So look, how many inputs does we have? It is like A, B, C, so three inputs, right? So we will write here as A, click enter, press enter, then B, press enter, then C, press enter. Okay, so let me just show it to you. Okay, now outputs are here as 01, 01, 02, 03, 04. So O1 is AC A bar B, O2 is this, O3 is this circuit diagram, O4 is also this circuit diagram. So let us just do here as output O1 enter, then output O2 enter, then output O3, then O4. Okay, now we have done the input and the output things. Click on OK. So this will give us the template that we have implemented, right? So double click on this four functions. the code editor will be opened here. Okay, now let me just tell you. Okay, these are the additional things, so you can just remove them. Okay, now after this line, line number 11, we are going to use something. Okay, so before that, let me just give you some hints, not hints, like rules, you can say rules. Okay, so uh, OR gate is used, this one above the enter. Okay, and gate is used as this AND. Okay, then not gate is used as tilde. Okay, this you will see on the keyboard on before one number digit. Okay, so this is all the thing. Now let's just implement the thing. Okay, so before like allowing on the output, make like write assign or leave this assign. I'll just let you know how you are going to. Okay, we are going to do the assign. Okay, so assign O1. Okay, what is in the O1? We AC. So uh, A and C. Okay, now after this plus means OR, so this one is OR. Then A bar B, so this is A bar and B. Okay, now the line has finished. Now next also like same, O2 equals to okay, A plus then it's the bracket, so it means that here it's multiplication, so like you can consider it as and. Okay, then B and C. Okay, okay, now let's just do the O3. So if we see, so A bar B, A and B bar. Okay, so we write here as A and B bar. Okay, then we see that this one is the OR gate, so OR C. Okay, then assign O4, which will be this one, A and B and the output, so it is NAND. Okay, so we can write it as A and B. Okay, and outside we are going to put an input signal which is not, so this not means it will be the NAND gate. Okay, now we are going to use C bar and B bar. Okay, so how we are going to do, so as here you can see the NAND gate other one, so we are going to use it like this. Okay, let me just, so NAND. Okay, now another NOT gate here, so which means that it is del C and B. Okay, so C bar B bar, so we have done this C bar B bar. So this has been done. I will give you this code like in the notepad. Suppose I am giving you this thing into the notepad. What you are going to do, just copy the whole file, copy it, okay, and paste it right here. Okay, save it, make sure it is saved. Okay, also make sure that this 3 option is right here. It means that this is the set as a top, that this file will be run as the top level file. Okay, now let's click on this, open the elaborated design. So I'll just show it to you. So you have to take the screenshots of all these what you are doing, because here your professor told that you have to do all the screenshot. Look, all the screenshot. Okay, so this was the work for the force functions. Okay, now after this I will just show you how you are going to use the blinky software, blinky thing. Okay, so this is all the circuit. Okay, So let us just do now the okay. So let us do the blinky one. Okay. So click on this design file. Click. Okay. So write blinky. I have written the blinky. Okay. Click finish. Okay. Now okay. So what we have to do here? Let me just read. So here it says that okay, this is activity 2. Okay, so take us of the after it. Okay, read through. Okay, let us just see what is inside this. Okay, here is nothing on this, so we can just do one thing like for example, let me just tell you. So we will just use one switch SW, okay, and one output which will be LED, which is the output, right? So I'll just click output. Okay, okay. Now, okay. Now make sure that you select this as top level. Okay. Okay. We click on the top level. Open the file. Remove the unnecessary lines. Okay. So after this, what I will do is to assign LED equals to SW, right? So this is what I want to do. Okay, now click on the adds a file, okay, and click on constraints, okay, create file Nexys A7. So click OK. Now click finish. Okay, now I have a bit work here, which will be Nexys A7 XDC file. Okay, so we will get this thing from the GitHub. Right now I'll just show you how you are going to do. Okay, so in the constraint, just open up the XDC file. Okay, now here you will get some code, okay, which we will do. Okay, so for example, what we have, this switches. Okay, I'll copy this switch, I'll paste it right here. Okay, now the next thing is this LED. Okay, so let me just take this LED. So this one is it. Okay, so what we are going to do, so we have this SW, so I will rename this thing as SW. Here output is LED, so I will just do this thing as LED. Okay, make sure that this is save, like save. Okay, you can press Ctrl S, so it will be saved. Okay, now the thing is that it is asking about how to run the XDC or the Bitstream, right? So for the Bitstream, you are going to click on this Bitstream, okay, and I'll just click on yes. So then now we will have to wait for about 5 to 10 minutes. I'm just pausing it. Okay, so this is now you can see that here you can see the upside. It says that the bitstream is being completed, right? And now you can see that this is the pop-up which you get it. Okay, so make sure that the FPGA board is connected. Then you click on Open Hardware Manager. Okay, after this, okay, so. Okay, so here you are going to open, click on open target, then auto connect. Okay, so here the board status will be showed that is it connected or not, and yes, the board is right here connected. Okay, as it's like open, and we need to program it. So how we are going to program? We are going to program it like click on program. Okay, so this blinky bit will be connected like automatically detected by the software, and now we need only to click on program. So when you program, the FPGA board will read the code. Okay, so now let me show you that what I have done in the code. So let me just open up my camera. Okay, so when I open up my camera, so like it's in front of you, so it's inverted, but I'll just okay, so look, this one is the first one, right? The first switch. So what I have done, the first switch will be output to this LED. So when I just toggle it up, so it will, okay, this one is okay. Okay, so it's actually disconnecting. So let me just program it again. Okay, so now you see I close it, toggle it down, so it's down. I up it, so it's blinking up, like letting on. So when I down it, it's again down, off, on, off. Okay, so this is how you are just going to work on this FPGA board. So thank you.